All right, are we all here? So I just want to say a couple of things. First of all, so you should be able to see test 2. I changed your grades in that, and I sent out a little note on that based on the questions that I thought were unreadable, or at least marginally unreadable. So I adjusted everybody's grade accordingly, and just look that over and tell me if you think there's something that looks not right. I didn't change any of your answers. I just gave you, I think the numbers were, I listed them in the thing, but I think it's like 13, 15, 17, 19, and 20. And actually, people did really well on these. Most people didn't get but one of them wrong. So I guess you could read it better than I could, maybe, or something. And then on question 12, I gave credit for A or D. For some reason, I had a 10 to the minus 2 next to one of the 1.8, and either somehow it didn't get printed, or I didn't get it in right, or something. And so the answer should have been none of the above for that one. But if you picked the 1.8, I give you credit for that also. So and then I put a copy of test 2 up on the in the file section. I could tell you just a little bit about your grades, right? You should know your test scores. So the total number of points in the class is hang on a second. Is 750 points in the class, and it's 100 3 times for tests, and then it's 100 for homework, and 50 for the learning catalytics, and then 100 for lab, and 200 for the final. So you can kind of figure out where your grade is. You can sort of figure out what your total homework percentage is. If you did any of these, if you did just a few of these, I rarely don't give everybody 50 points. There might be 1 or 2 people in class who miss almost all of them. But if you were there for a couple of them, you'll probably get all of the 50 points for that. The labs, most of you guys have done really well in lab. And so you can just calculate what your percentage is, right? If you have whatever your scores are on the 3 tests, plus the homework, plus the learning catalytics, plus your lab grade. I don't know if those are those probably aren't up, but you can probably look at your scores, or at least you have your scores. I don't know, actually, if the graders put those up. One of you guys can tell me. Maybe can somebody jump in and tell me?
They're still not in the grade book, but we have them back.
You're talking about on the lab, in the lab class part, right?
I'm pretty sure there's only one course.
One set of scores on there. All right. I'll have to put those up. Hopefully you have most of your labs back. I don't see a big stack of labs over there, or maybe I do. I'll just try to look at that tomorrow. Fires I have to put out. But anyway, most people are doing pretty well on lab. And so you should be able to get a pretty good ballpark estimate of what your percentage is here, right? So if I say, if we're not going to do this, but let's just say we had a 90, 80, 70 curve, right? 60, whatever. And so this would be, whatever this would be, 675. It'd be 75 points, right? 600, 525, and 450. So look right, because 10% of that is 75, and I just keep subtracting 75. And so greater than or equal to that would be an 8. Usually by the end of the semester, this is like an A is more like 85%. And so you could figure out what that is, 85% for an A. B is greater than about 75 or 4 maybe, and C and so on. And so you should be able to kind of get an estimate, you know, of what you need to make on the final to do this. And I'm not making any promises what I'm going to do with this, but I'm probably going to knock that down some more, like 5 more points or something. I'm not going to grade you guys very hard this semester. So if you want to struggle in my class in the semester, this would be the one to do it. If you want to just get with me and have me sort of work this out for you, I can. A couple of you have emailed me that, and it's on my plate to get back to you, but I've just had a lot of other things that I've been trying to get organized here. So, are there any questions about this?
About the lab grades, if
Yeah.
we didn't end up paying you $10 before we left, is that why our grades aren't in?
No.
Or
Your-
like it's not
your-
there?
Your
Sorry.
grades aren't in because that part of my hair isn't on fire yet.
Well, Whitney said that hers, like she could see hers, so I didn't know if that.
Oh,
Yeah, mine are in there for in the lab class. I have up until what was due on like March 9th.
well, we had different TAs doing the different classes.
That's true. I was in a different class.
If you're in a different class, I don't know who was my TA. I think it was Taylor Valdez. I'll just have to look at that. Hopefully you guys have a pretty good sense of how you've been doing on the labs. And so that's not a huge crisis. If it is, just call me or send me an email and say, hey, I'm really worried about what I was doing in lab or something. And I'll look at that sooner rather than later. But I'm just trying to manage these other things that have to do with the all the online stuff for the grading. So, but I appreciate your comment, and I will try to look at that hopefully tomorrow sometime and see if I can I can give you guys a sense of that. But like I said, everybody's been doing pretty well in lab, so there shouldn't be like a huge uncertainty in this number. You know, you might guess 90% or 95% or something like that, or 98%. But you should be able to figure out, you know, where you are on everything but the final, right? And then you can figure out how many points you need on the final based on this kind of thing to see what grades you need to make.
Dr. Trail,
Yeah.
I looked and it says that the lab course on Canvas isn't published, so that's why we can't see it.
Oh, I wonder if he's been putting the grades in there. I will take a look at that. Yeah. All right. I'll try to do that. No, realistically tomorrow. I've got another meeting after this one, and so all right. Okay, but hopefully that's not like the linchpin in you guys figuring out where your grade is, right? Hopefully. All right. If it is, tell me. All right. So that's that. Let's see. I already said you guys can have a sheet on your final. Probably going to run the final from, is there anybody who can't make the 8:30 to 10:30 window for the final for whatever reason? All right. I'm going to give you like a 2 hours or 2 hours and 10 minutes or something like that between, I think, 8 and noon. And so you'll have a little room there. I would say don't wait until the later time period. Try to just take it between 8:30 and 10:30 if you can. All right. So any other questions? Any physics questions? Someone sent me an email and said they wanted to know the answer to the question of, this isn't very good. What it was, I think from test 1, maybe. I don't remember the mass. I'll just pick a number. So what's the buoyant force on a 10 kilogram block of concrete at the bottom of a lake? So can anybody tell me what the buoyant force is equal to while I dig up the equation sheet? What is Archimedes' principle?
The buoyant force equals the weight of the displaced water.
Perfect. Um, so, um, so and when I submerge something like a block of concrete, how much water gets displaced? Not numerically. I don't want a number, but what property of this block of concrete tells you how much water got displaced?
The weight of the block
So the weight of the
times the
block,
density.
both of those maybe? Both and neither. You can use both of those to calculate what you want. How much water gets pushed away? What property of this block tells you how much water gets pushed away?
The volume?
Volume, right? So you can get it from the weight and the density for sure. But you have to figure out what the volume of the block is, because that's how much water gets pushed out. And so the volume is we remember the density formula is mass over volume, right? And so volume is mass over density. And so you can, of course, use those two to calculate the volume. And that's what you have to do, in fact. You have to take the mass of the block and divide it by its density. And so it's 10 kilograms. And if you have the equation sheet in front of you, you can see that the density of concrete is 2,000 kilograms. Am I off the screen? Probably. Yeah, well, that's better. 2,000 kilograms per cubic meter. And so the volume is 10 over 2,000, which is 1 over 200, which is, let's see, 1 over 2 is 0.5, 1 over 20 is 0.05. So 1 over 200 is 0.005. That's
Yes.
I'm sticking with it. Cubic meters, right? And so that's the volume that got displaced. So how do I use that to figure out the weight of the displaced water?
Use the density of water.
Exactly, right? And so I can calculate the mass of the displaced water by multiplying the volume of displaced water by the density of water, right? The mass of the concrete block is the volume of the concrete block times the density of concrete. The mass of the displaced water is the volume of the concrete block times the density of water, right? And so that's 0.005 meters cubed times, if you look it up, the density of water, you guys probably know this already, is 1,000 kilograms per cubic meter, or 1 gram per cubic centimeter. And so 1,000 times 0.005 is probably 5. Right, so the mass of the displaced water is 5 kilograms. The weight of the displaced water is just the mass of the displaced water times G, which is 5 kilograms times 10 meters per second squared, which is 50 newtons. I'm pretty sure that wasn't the mass that we're talking about in the problem, but it shouldn't matter, right? Should be easy enough to do. Okay, ask me another question. Not that you asked me that. Are you guys studying for their finals? Probably.
I have a question about like the makeup of the final.
Okay.
So do you know roughly like what percentage from each exam will be on the final, or
I'm
kind
gonna,
of
so we have covered, I think we covered 8 chapters or 7. I think we've covered 8 if you count the properties of light. I try to just spread it evenly over the chapters. So with 8 chapters, I will probably have maybe 5 questions per chapter, something. That's what I'll be shooting for. And so that might weight the earlier tests a little higher, because that first test, I put 3 chapters per test, but we just didn't cover enough material in the last 2 sections to do that. And then the last one on properties of light, I won't cover that one as rigorously, because there's a bunch of material there that, even though I put it in the videos, I decided to kind of leave off it. I gave you guys that outline yesterday. I want you to know Snell's law, but there are things like polarization that we didn't cover in there, and some other topics. And so I would probably have fewer questions on that, or maybe really basic questions on that, probably. Usually when we have these help sessions in the classroom, you guys have questions for me. Will you just have more tomorrow, maybe?
Yeah, I mean, I just switched to my iPad because I haven't had a chance to look at the exam 2 since you fixed it. So I was going to try to pull that up to see if I had any questions, but
Okay. Well, I can hang out for a few minutes if you guys just want to look at that stuff. But we can do it tomorrow. Is there anybody who can't do 5:30 tomorrow?
I have work.
You work at 5:30? Who is that?
Just watch it later. This is Denise.
Oh. Okay.
I'll be.
Are you working all day?
No, I work 4 to like 8, depending on what I'm doing.
Well, I'll tell you what. I will. Is there anyone who would come to one earlier in the day?
I can.
So I'll leave the one at 5:30, and I'll. What's a good time? Denise, pick a time earlier in the day.
1.
Okay. So. I'll set up both of those tomorrow, and then you can come and listen or ask questions, and if nobody's there, I'll just work. And so I don't have any problem with that. So, and I guess I'll just record them and put them online if you want to. I guess that's the good thing about this, is we can just stick them up there. All right, well, that's all I have. If you guys want to ask me more questions about anything, I'll just hang around for a few more minutes until that's all done. But otherwise, I guess we're done, unless somebody pulls up a physics question for me, or any question for me.
Can you do an example over gauge pressure?
So yeah, so what is gauge pressure really? Why do we use the term? It's gauge pressure as opposed to what pressure? These are all open questions for everybody. So gauge pressure is a pressure difference. Usually, the reason they call it gauge pressure is because it's what you measure with a gauge. So if you have like a tire gauge, right? If you put the tire gauge on your tire and it reads 0, that doesn't mean there's a vacuum inside your tire. That means the pressure inside the tire is the same as the pressure outside the tire, which means you have a flat. And so the gauge pressure is always measuring the pressure difference. And so an example would be, what is the gauge pressure? Spelled that wrong. Like, what's the gauge pressure 5 meters under the surface of a lake? Right, so here's my lake, right? Does anybody remember the formula for pressure at a depth h in a lake, in a fluid? I'm not asking, I'm not saying you should. The formula for pressure, or the formula for gauge pressure in any liquid is rho gh, where h is how far down you are. What it really is the gauge pressure in the lake, because you're not adding atmospheric pressure to that. The pressure is just how much stuff you're under, and you're fully under the atmosphere as well. We don't count that. Usually when we're talking about the pressure at some depth in a fluid, you're talking about relative to the top surface of the fluid, and that's a gauge pressure. And so this would just be, if you wanted to, you can call it peak gauge. Usually we would just call it the pressure. Right, and so that's 1,000 times 10 is 10,000 times 5 is 50,000. So 5 times 10 to the 4th. And then let me try that one more time. And then the units, I can see a kilogram meter per second squared in the middle there, so I can call that a Newton. And that leaves this guy and this guy. And so one of them cancels and I get a Newton per meter squared, which is what I expect. That's a Pascal, that's a unit of pressure. So I could say 5 times 10 to the 4th Pascals. But gauge pressure is just a difference, the pressure difference between two positions. What else? Was that Jordan? Who asked me that?
I did.
How do I tell who's talking on this?
Does it not show you?
I don't think it does.
Oh, this is Denise.
Oh, there we go. The only reason I can tell, Denise, is because you're not muted. Everybody else is muted. But there's probably some technology here that I don't understand, because I can admit that I have been completely lost in the technology of this stuff.
The microphone also goes up and down with a black thing to show you who's talking if multiple people are unmuted.
Oh, I'd have to have everybody on screen though, wouldn't I? Because I've got my screen blown up so that when it records, you guys get this whole thing. So
Yeah, I guess you'd have to have that or the participants thing opened up
oh,
to know for sure.
I got nothing. All right. Anyway, another question.
Could you do one on hydraulics?
So hydraulics usually means like Pascal's principle. Oh my gosh. I don't know if I can pull one out of my head on that. Let me just think for a second.
There was one on the homework that was like, if the worker pushes down, like on one end, how high does it raise on the other end?
Right.
But
So
it's-
there's one in your notes on that where I did it with a car. And so you can, so back when they used to make soft drinks out of bottles, in bottles, or alcoholic beverages or whatever, when they put things in bottles, you could take a bottle and people would do this. You fill it up to the very top with a liquid, right? And then you could slap the top of the liquid really hard, just so you fill it up with water or pop or whatever, all the way to the top, and you could hit this really hard. And so the you exert a large pressure here, and down here, the force is equal to the pressure times the area. It's the same pressure. It's actually a little greater because you've got all this liquid here, but that's not very much. That's just 6 inches or something of water, and the pressure at this height difference isn't very big. But taking the same pressure, the increased pressure up here, and having it over the much larger base of the bottle produces a much bigger force, and it breaks the glass. And so it's kind of like a party trick people will do sometimes: fill something up to the very top and just hit it really hard on the top. Just while it's in their hand, it'll just break the bottom of the glass off. So that's an example. But so the example we talk about is how your car gets lifted, and this is like a caricature of that. But it's the same idea. So you have two pistons, right? One over here, and so you exert a force here, and since this has an area here at the bottom of this piston, right? It's a round bottom like you have in a pump or something, right? And so P1 equals F1 over A1, right? Pascal's principle says, as long as you're at the same height in the fluid, the pressure is the same because the pressure gets distributed everywhere. And so that means P2 here is equal to P1, as long as they're at the same height. Otherwise, it might be slightly different if it was slightly higher or lower. But this force here, Pascal's principle says directly, a force exerted on a closed system, a fluid in a closed system, gets transmitted undiminished to all parts of the fluid and its container. So that's the words of Pascal's principle. And so here I have another piston, and this has got a much bigger area. This is A2. So P2 equals F2 over A2. But that means that since P1 equals P2, then F1 over A1 equals F2 over A2. Or we could say F2 is equal to A2 over A1 times F1, right? I just multiplied this side by A2. And that means that this force is increased by the ratio of the two areas. And so if this area is 10 times bigger than this, then this force is going to be 10 times bigger than this. And so that's the principle of hydraulics. And so, we did a numerical example with that in class. And so if these are round, I could say, look, this is pi times R2 squared over pi times R1 squared. F1, or I could say F2 is equal to the pi's cancel. And I can just get R2 over R1 times F1. And so if this guy's radius is 5 times this guy's radius, then, sorry, that's squared, right? Because these two guys are squared. If this is 5 times bigger than that, then if, is that okay? I don't know what else to do for that.
You're off the screen a little bit.
Aha,
Yes, that helped a lot.
all right. This thing constantly defocuses. All right, what else?
I have one from the first exam.
Okay,
It says a muffler is put on a motorcycle, or not, no, sorry, wrong one. A wing of area 10 meters squared has air flowing at 40 meters per second over it and 38 meters per second under it. What is the net upward force on the wing?
so if you're, here's my airplane, right? And it's got a tail back here somewhere. I'm looking at it from the bottom, right? So there's the, and we're saying the area of the wing is 10 square meters or something like that. Here's the propeller. Right? It's got wheels coming out this way. We're looking at it from the bottom. It's got an area of 10 square meters. And so we're saying as the plane flies, the air going over the top is 2 meters per second faster than the air going over the bottom. And so small planes are kind of designed this way, to have the curved top and a flat bottom. If you look at the ones that a single engine plane, like jets aren't really designed this way, but small prop planes are. It gives you a little glide, and because of the way this thing is curved, the air has to get to the back to the same spot. The air has to go faster over the top, and since it's got some inertia, it's basically getting to the same spot, and so it's going faster over the top. And so this is a Bernoulli's principle problem. Does anyone remember Bernoulli's principle? It's an equation. So it's pressure plus 1/2 rho v squared plus rho gh is constant in a fluid system of some kind. This should look a lot like kinetic energy, and this should look a lot like potential energy, right? mgh versus 1/2 mv squared. But we don't look at those things for a fluid because you don't really have a specific m. And so usually we're talking about the density. And so when you write these with densities instead of masses, they become pressures. They have the units of pressure. This would be the work done. The pressure would be sort of related to the force and the work done. And so this is like the work energy theorem for fluids. And so what it means is you can apply this to different points in a fluid. And so I could pick, this is 0.1 and this is 0.2. And I could say P1 plus 1/2 rho V1 squared plus rho g H1 equals P2 plus 1/2 rho V2 squared plus rho g H2, right? The rho is the density, the P is the pressure. And so there are a couple of things you have to sort of notice. One is that wings are pretty thin, and so the height difference between these two is negligible. You don't have to neglect it, but since they didn't tell us what the height difference is, we're going to assume it's real thin. Wings are thin. You have to go a long way in air to get a pressure change due to the weight of the air, unlike in water. The whole atmosphere is the same weight as 10 meters of water. And so And so both airs are moving, and so there's a slight pressure difference. If we want to know the upward pressure, so P1 is pushing up and P2 is pushing down. And so P1 minus P2 is equal to 1/2 rho V2 squared minus 1/2 rho V1 squared. And that's the pressure difference is what gives you the net force. The force is equal to P1 minus P2 times the area. I forget what the question was. It was something about did it say what's the pressure difference? Or what's the force? That's the question, right? And so we have to take the difference in pressure between these two positions and multiply it by that area.
Yeah, what is the net upward force?
Yeah. And so in some of those videos, oh no, this is before the video. Oh my gosh. Yeah. I did some demos with pressure where I blew through those Venturi tubes, and they had 3 little columns of liquid that came up, and where the air was moving the fastest, the column was the tallest because it was the lowest pressure above it. And so that's kind of what this is. And so this becomes this pressure difference, P1 minus P2. All I need to know is the difference is 1/2 rho times V2 squared minus V1 squared. Right, and that's equal to 1/2. So the density of air is about 1.25 kilograms per cubic meter. I think it maybe says 1.29 on your equation sheet. Let me look real quick. Yeah, 1.29. Maybe I'll put a 9 in there. It doesn't really matter. It depends on where you are on the planet and what your elevation is and all that stuff. And then this would be 40 squared minus 48 meters squared over second squared minus 38 meters squared over second squared.
Dr. Trail, you're off the screen a bit.
Thank you.
Thank
I don't know if I can do that in my head. Somebody can do that for me. So that's 1600, and that's so 1600 minus 2 times 2, so 4 times, so this is 1444. So that would be 156. Somebody get a calculator.
Yeah.
156.
All right. And so I multiply that by 1.29, which is adding 30% to that, which is probably about 50. So 206 values. It's 103, maybe 100, somewhere around there. When I multiply this by that,
Ends up being 100.62.
100.62. And so that's pascals. And so then I have to multiply it by, so that's the pressure difference, right? That's the net pressure on the wing. It's got a larger pressure on the bottom because the air is moving slower, and a smaller pressure on top. If you just look at these two equations right here, right? Since these two have to be equal, if V2 is larger than V1, then P2 has to be larger, P1 has to be larger than P2, right? If this guy is larger than this guy and they end up being equal, then this guy has to be larger than that guy. And so usually when you have slow moving fluid, you have a region of higher pressure. And so that pressure difference, 100 pascals, you multiply it by the area. And so it's 100 pascals times 10 meters squared, which is 1,000. A pascal's at Newton per meter square, and so it's just newtons. Hopefully that was a choice.
It was. Thank you.
But What else have you got? I'm ready for another one.
Can we do a problem where that talks about receding sound source and then like a sound approaching you and then you like receding a sound, like one of those problems?
Yeah. So let's just make one up. So a car is approaching me at 20 meters per second with its horn blaring at 800 hertz. What frequency do I hear? So first of all, would it be a higher or a lower frequency?
Higher?
Yay, higher, right? Because if the car is driving towards me, I don't know how to do this. Right, playing a sound, as it's moving with the sound, it's going to crunch the waves together. So where behind it, I might see a bigger spread in the waves. In front of it, I see a smaller spread, right? And so I see a shorter wavelength. If I'm sitting here listening, hopefully not directly in line, right, then I get a higher frequency, right? And if you look at the formula, it's the frequency observed is equal to velocity of the wave over, let me just, don't write this down yet. Velocity of the wave minus the velocity of the source times the frequency of the source. I think that's right. That should be somewhere on your equation sheet.
Yeah, that looks right.
Yeah. And so that would be, you know, you could qualify this by having a different temperature, and then the speed of sound is slightly different. But usually we just do these at room temperature, which would be 344 meters per second, and it would be minus 20 meters per second times 800 hertz. Right. And so that would be about a part in 16. So I'm going to say roughly 835.
I got 849.
849, thank you. That was awful. Yeah, 5%, that would be, a 20th would be 40. So it's got to be bigger than 40. Yeah. I went the wrong way. So what would happen if it was going away from you at the same speed? How would this equation be different?
You add the 20.
Yep. And so roughly speaking, it would just take it 49 the other way, roughly speaking. And so that would be maybe 750. How does this equation look different if the car is stationary, but I'm running towards it? So the car's still playing its horn at 800 hertz, but but it's just standing still and I'm running at it.
Does the fraction just flip?
Yeah, kinda. So you just have the frequency observed is equal to the velocity of the wave plus the velocity of the source over the velocity of the wave. That's if I'm running at it, times the frequency of the source. And so if you look on the equation sheet, it looks like this. Is velocity of wave plus minus velocity of the observer, velocity observer. I always get that wrong. Velocity of wave minus plus the velocity of source times the frequency of the source. And so you use the top sign if they're approaching. So the top sign in the numerator would be if the observer is running towards the source. The bottom sign is for receding. And so if I were running away from the car, I'd put a minus sign here, right? And the bottom sign, the denominator is what the source is doing. So the top is what the observer is doing. The bottom was what the source is doing. Once again, if the source is approaching the observer, that becomes a minus. It's the top sign. And if the source is receding from the observer, it becomes the bottom sign, which is a plus.
Dr. Trail,
Yeah.
kind of circuits and capacitors are kind of the same.
Say that
Right.
again.
Like the circuits equations and the capacitor equations.
Okay, by circuit equation, you mean resistor equations, right?
Or yeah, sorry.
Yeah. No, that's okay. I just want to be clear because they're both in circuits. So series resistors is 1 over R series is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus ... That's where you have a bunch of resistors in a row, and you want to know what their total resistance is, right? And so you do that to them, add up 1 over each of them, take 1 over the whole thing, and that's the oh gosh, I got it backwards. I was thinking capacitors. Well, if you weren't confused before, you will be now. Sorry. The charges, the electrons have to go through each resistor, and so the resistors add in series. And then in parallel, if I have like that. Capacitors are the opposite. So if I was trying to get capacitors on the same thing, here I would say, if I have 3 capacitors in parallel, Capacitors add like that for parallel. But capacitors in series, add like that. Yeesh. I wish there was some way to edit that out of that tape.
Could you move it up a little, please? Thank you.
Yep, sorry about that. Is it all on there? I think so.
No, it's not. Can you move it up a little bit more?
Yeah. It's weird because it shows it on mine. Can you see the top of it?
No, but I
No.
can't see the bottom of it either. Okay, there it went. Sorry, it was actually my bar where I hit unmute.
Oh, okay. All right. What else? All right. Let's stop. I'll hang around for a minute if anybody wants to ask me any other questions. But tomorrow at 1 and then tomorrow at 5:30. Is everybody good with that?
Yep. Thank you, Dr. Trail.
Thank you guys very much.
Thank you. Love you, Dr. Trail.
Thank you guys, everybody.
I'm your biggest fan.
I'm yours, Jordan.